You know, Jennifer makes a great point, but many of you may say she's still playing it down. In fact, I would say chances are high that your Wi-Fi network has quickly moved from this nice-to-have right through the must-have phase and is probably staring quite directly at critical phase. Well, you know, one huge challenge with being successful at this is that Wi-Fi operates within an unlicensed frequency band. It's the very ubiquity and ease of use that we all enjoy that is threatening to bring your network to its knees. Interference is the evil antagonist in our otherwise successful deployment. But what becomes so important here is the ability to accurately recognize interference. Questions like what is it and where is it and how is it impacting my network? And these have not been easy questions to answer. So now when you ask yourself, you go, can my IT department deliver a priority one service level agreement, and would I do that on wireless? That's kind of scary. SLA and wireless? I'm not so sure. So what's traditionally held things back? Well, there's been speed. Well, we solved a lot of that with 802.11n. We've got endpoints coming out our ears now. Now we've got the iPad and everything else. Reliability issues with limited spectrum and how we address interference. And then, of course, security, how to move identity between networks. So let's get started. I want to give you a few keys to the show. Here's what I want you to watch for. First of all is demand. And the fact is, do you agree that there's a demand for business mobility? Do you agree that it exists for you? Wireless interference, is it a real threat? And then, of course, spectrum analysis. As you look at this throughout the show, you can't even monitor or hope to mitigate what you can't see, right? And this is useless if it's not accurate. So watch for network-level integration and make sure that we've covered all the points there. Security, from wired to wireless and all points in between, the question to ask is your security just as mobile as you are? Because what it boils down to is control. Control for the chaos, and that's not just for your RF environment, but your mobile area too.
Jim Florek, welcome to TechWise TV, man.
Jimmy Ray, good to meet you.
Thanks, man. Hey, you know, I brought you in the lab
Yep.
because this is where we actually do the meat and taters of everything comes with TechWise TV. All those folks talk about this clean air stuff. It's time to kind of, you know, this is where we make the rubber hit the road.
Well, I think we'll have fun.
Okay, so, you know, what the big thing here is let's break this down and find out what's going on in the hardware. I'm a hardware guy myself. I'm really into hardware design. And some of the claims are being made about clean air, I'll be honest with you, I find really hard to believe. I mean, the fact that we're integrating spectrum analysis inside of hardware and that we're getting line rate performance, I mean, that's, you know, any engineer out there worth their salt that's done anything with wireless knows that you just don't do that. You go into monitor mode, you got to pay a performance penalty, or you don't service any clients. I mean, you've got probes you set out and you got client access points for clients you set out. You know, I mean, there's... But you're telling me that those days are over.
Yep, they are.
Okay. Well, take it away, man.
We actually, let's get our first slide up here. Let's set the problem up first. Wi-Fi chip is a communications processor, first off, okay? So its primary job is to demodulate Wi-Fi traffic and put it out on the wire. Now, we've layered a lot of stuff on top of that. We've asked it to do security analysis. We've taken all the information that we can off the backside of that chip to control the radio frequency that we're using and analyze the spectrum. But it can only go so far. Wi-Fi chip, typical resolution, 5 megahertz.
5 megahertz, right.
Okay,
absolutely.
You got tunable steps. And you can't mess around with that a whole lot because it's doing things at line rate. Okay, so when you're talking 5 megahertz resolution, what you're really getting is you get these blobs of information. Okay, but the information could be a lot smaller than that. But we can't really see. So what we see is we see this bloom. That may or may not be a problem. Okay. But it's certainly high. Now, the thing that kills us on that is that Wi-Fi traffic, being bursty in nature, can oftentimes reach high duty cycles, collisions. You get fragments coming through. You get traffic that is just below it. What a Wi-Fi chip says is if I can demodulate it, it's Wi-Fi traffic. If I can't demodulate it, it's noise. So there's this whole huge classification of noise down there. Same piece of spectrum. You get down with a spectrum analyzer. You take a look, you find a Bluetooth down there, you find a microwave oven down there, and we know exactly where those things are.
Well, that's why we pay $60,000 for a spec-an, right?
That's exactly why you pay $60,000. Now, spec-an, we talked about this at one point in time. That can be a very confusing piece of equipment. Okay?
Oh, yeah. Oh, absolutely.
And you can get a lot of opinions looking at it because it's very highly dependent. One of the things that we did with Spectrum Expert was provide very crisp, clear analysis. And that information was not an opinion. It was a fact. Okay, so we could tell you what it was. We could tell you exactly where it was and what it was doing to you. So what we've done with that is we've integrated this into the AP. We've integrated this into the AP as a parallel process.
Okay.
Okay. So what we're talking about with the system is the AP sits down here. Sensor D, which is the controlling software.
Okay,
and
this is
Sage,
an overlay of the wireless network, right? My WCS.
Absolutely.
Okay,
Right.
This is not the chip. This is the AP.
This is the AP.
Very well.
And this right here is the chip. This is the software component, and we do it at the AP because you're talking about a tremendous amount of information that's coming through. We're looking at a gigabit per second coming out of an antenna that we've got to analyze, and we've got to do this without impacting customer traffic. Okay? So the way that we do that when that's coming in, we identify, if you go back to the previous slide, we see a blob like this. We can get some information off of that. We index that. We say that's potentially something. Okay?
Yeah.
And we drop that down to a lower level processor into the Sage hardware. And that's actually running parallel to the radio and the iOS. Okay? So while we've got customer traffic flying through, if we can demodulate it, we pass that straight through. If it's something that the chip considers to be noise, we drop a chunk of that out to the Sage processor and we do a full analysis on that.
Okay.
So if we drop down into the actual chip block diagram.
Oh, now here we're talking.
Okay.
This is good stuff.
So we're going to filter that. We're going to align it. We're going to derotate it. Okay. We're going to drop it into the FFT windows. We're going to pull it out after it's been fully processed. It drops into what we call the Dave. All right. And the Dave is sort of a free-for-all. We can take multiple samples, multiple chunks at the same time. And what we do with the index is we say we think it's 1, 2, 3, 4 categories. We triage that. And then the Dave lines up with just the things that apply to those and does the full analysis on it. And what it's going to do is it's going to look at the signal and see if it can absolutely positively identify it. Is there a sync word in there? Is it consistent with the pulse repetition frequency? And we're going to put that to a classifier. Now, the entire thing...
Okay, wait a minute. I got to know something, though.
Okay.
On the Sage, is there an error code on the Sage that sends back to the Dave to tell it to stop doing stuff that says, I'm sorry, Dave, I cannot do that?
Well...
That's sorry, man. That's an old Space Odyssey. Go ahead.
No, I remember that. I remember that. Actually, the plug for the Dave is right over here. Okay? Yeah, so you just unplug it if it gives you that much trouble. Okay. So once the Dave's done processing it, we know what it is. Okay? We know where it is in spectrum, and we know how it's affecting the Wi-Fi. The reason this is so important is because it's on the AP itself. All right? When we're talking about where the problem is going to be, it's going to be local to that AP. We can't do this off-platform with software. We have to do it on the sensor itself because this is serving client traffic at the same time that we're analyzing.
So now, oh man, this just is. Oh, now, but wait a minute. Now we've been doing radio resource management for a while.
Yes, we have.
And a lot of folks out there are doing it as well. And so if I'm an engineer watching this, I'm like, look, man, I've seen this from Cisco before, and I've seen this from other competitors before. I mean, you're really honest to goodness talking about hardware.
We're talking about hardware making decisions on its own.
So you're putting this in. I know this says the AP, but do you really honestly mean the AP, or do you mean an overlay?
The difference here, no, this is in the AP. The difference here is what we're dealing with in RRM and what every other competitor is dealing with when they talk about radio resource management is this level of information right here.
Well, you only got so much you can do.
We only got so there's noise and there's Wi-Fi. That's all there is.
That's
okay?
right. That's right.
Turns out noise is a very confusing space. A lot of the noise comes from Wi-Fi. Okay, and we talk about avoiding interference, but a lot of the times the interference that we're avoiding is ourselves.
Well, I mean, it's
okay.
ISM band. I mean,
absolutely,
it's unlicensed.
It's a free band.
Exactly.
Absolutely. Okay, you're breathing your physical air. So that's what makes this so critically important to identify what it is that we're avoiding. Okay. RRM can open up the channel. It can move around. We can overlay our channel plan and we can do power control so that we don't interfere with ourselves. But when you talk about something that Radio Shack sold or somebody else sold into a consumer environment, most users don't understand that you can't just bring a wireless device into a mission critical Wi-Fi.
Very true. Very
okay.
True. Very
and when you have something like that, we can do things with that because we're generating actionable information at the chip level that can be used by the system to add and augment that information. All right? Yesterday, this was the information we had. Today, this is the information we had, and we can do things about that. Wow. Okay? Microwave oven, probably not going to move. We know that a microwave oven comes on around lunchtime, 2-3 minute segments it's going to impact. We can specifically identify where it's impacting because you'd think that a microwave oven, everybody knows, is just channel 6 or 11. But when in reality, you go down to Best Buy or somebody else and start firing up microwave ovens, they're all over the board.
Oh, true.
They're
I'm like 6 and 11. Like, I see them on 9 all the time. So,
okay.
yeah, that's true.
Bluetooth, probably not a big problem. Can be a big problem. You might have class 3 Bluetooth in there running at 100 milliwatts.
Okay, wait a minute. So, now let me see. Now, I know you got another slide here, but let's
Sure.
let's take
Break
a step back here. Now, what I'm looking at here, just so I understand, so this is actually my AP.
Yep.
I've got my antenna out here
Okay.
that's transmitting and receiving signals.
Correct.
Now, I'm not really interested in the transmit side. My big thing is the receive side. So I get my .11 signal in here. It's being clocked in by my UART. I've got my CPU up here. That's keeping time. I probably shouldn't be writing upside down, huh? I got my CPU that's timing everything in here. I've got my normal transcoding processor up here that is actually just really taking these frames and I'll just call it the .11, and it's converting them to my .3 Ethernet frames and kind of send them on their way to the LAN. But then what you're telling me is that so if I receive something here that is anomalous or outside of tolerance and classified as anomalous, I've got my SAGE down here is where this processing goes, and it takes it over from here while I'm still servicing all these. Let me get fancy dancy here. And while I'm still servicing my clients this way, my SAGE is down here processing all this anomalous traffic.
Correct. We've got
at line rate.
Yep, at line rate.
Spectrum analysis at line rate.
Spectrum analysis at line rate. So we've got another 250,000 large gates in here. We've got an arbitrator that sits right there. Okay. If it's Wi-Fi, if we can demodulate it, it goes straight through. Okay. If it's not Wi-Fi, we sample it, we drop it. Okay. And remember the indexes I told you about. We see something interesting. We drop it. That processes in parallel to the client traffic. So we don't hit the client traffic or throughput, not even one little bit. Okay. And we've actually held the duty cycle up to the point where the AP completely fails and we can process at line rate. All right. So the reason that we do this, okay, is again because not everything that's in the spectrum is Wi-Fi.
Yeah.
And the things that aren't Wi-Fi are stealing your bandwidth, and we need to know about it at the point that we're seeing it, so that we can make decisions about it. And that's the thing. That's the reason that we put it into the hardware. When you have an overlay system, you've got software lag time. Okay.
Well,
you also have to have human intervention because somebody's got to take a look at that and decide what it is. Okay. So it turns out our classification is pretty good. When we say we know something, we know it.
Well, if it's spectrum analysis, of course you do. Spec ends are right on target. I
That's
mean,
right.
Software has canned scripts, and you've got canned definitions you're using.
Right.
Spec end is what it actually honestly is.
About another 250,000 logic gates, and we have extremely tight coupling with the receiver, so we can talk back and forth to each other and make it work.
Dude, I can't even believe it. Well, Jim, I know we're kind of done with the segment here, but this is great stuff, man. I really do appreciate it, and heck, what a great product, man.
It's been fun.
Thanks, man.
Thanks, Jimmy.
Jim Ford, welcome back to TechWise TV, man.
Good to see you.
Well, so, we've kind of built out this whole clean air thing, but we haven't seen the hardware in action.
Okay.
And so let's actually put the rubber to the road.
Okay.
You got a couple slides you want to show us, and then we're going to jump right into this?
I do. Yeah,
okay, well, let's jump right in, man.
Talk about interference first, okay? So first off, we know Wi-Fi does collision avoidance.
Yep.
Okay, it's a very polite protocol. Listen before talk.
Yeah.
If it hears energy in the channel, it won't transmit, it won't receive, it won't do anything because it's staying clear of maybe another station already using that channel.
That's right.
So things like cordless phones, 2.45 gigahertz phones, TDD ones, older style, very, very bad for Wi-Fi. 100% duty cycle, never gives the opportunity at the Wi-Fi AP or the client to ever say a word, okay? Video cameras, very popular with security. We see them popping up in doctors' offices, hospitals,
all over the
well-meaning people trying to do a better job, okay? Not realizing that they're taking out Wi-Fi. You got Wi-Fi busy neighbor scenarios, you've got off-channel rogues, you've got all kinds of nastiness out there from a security perspective. Microwaves, you got busy people sleeping fast, eating bad food. You got microwaves.
That's right.
Okay. Bluetooth headsets can be a problem. DECT phones, very popular. You see them a lot in headsets for popular phone systems now. All of these things degrade Wi-Fi. They use your bandwidth, and they don't let you get clients through. In an extreme situation, okay, you can actually get so intense that nothing can talk in the environment, and that's what we're going to demo today. The ability that the AP has the hardware and the knowledge of what's going on in that spectrum all on his own without working back through the controller can make a decision that a channel is now permanently blocked because of an interference device. And keep in mind, because we have that SAGE hardware built into the AP, we know that that's a non-Wi-Fi signal, not just an anomaly happening in Wi-Fi. And that's the difference between the way we were doing things and the way we do now. So what we're going to see is we're going to see a video camera is what our demo is going to be. Come on, it's going to completely block the channel. Channel 6 is the one we're using. We've got a video demo running over here. We're going to see that video demo stop. We're going to watch this in Spectrum and show what's going on there. The AP all on its own is going to pick a new channel, and then it's going to register that with the system, and we'll take a look at the information that's done in the system. Let's go over to the demo.
Okay, let's switch. Let's move to the laptop here.
Okay.
Okay.
All right, so first thing we're going to look at is the Spectrum that we've got in here right now. On the laptop, you can see the video demo that I've got running in the back.
Yeah, you got a nice
operating in channel
saturated
11.
signal here.
Right, okay. So what we're going to do is we're going to interrupt that with a video camera that I've got on channel 11. And when that happens, it's going to stop the transmission from the AP. But the AP is going to recognize this as a video camera, as a catastrophic event, and it's going to switch channels, and the video is going to pick back up. And this should all happen pretty quickly, about 45 to 55 seconds. The AP will have it within 30 seconds. All right, so I've fired up the video camera. You can see that the demo is stopped. You see the video down there at the bottom coming in. Okay,
yeah,
that little red line is the duty cycle from the camera. If you take a look up at the top, you can also see the signal up here. And that's exactly what the Wi-Fi is seeing right now, is that continuous 100% duty cycle in that channel.
Saturating that channel down.
Saturating it.
Yeah, I can definitely see that.
Okay. AP's picked up, and now you see the AP show up over here on channel 6. It recognized the interference, it changed channels, and the demo's back running. So what this means is you can get a call
Dude,
to help.
That was pretty fast, man.
It was very fast. It's watching the AQ every 15 seconds. So we should see a response time between 15 and 30 seconds, and then of course the client has to reassociate.
Yeah, but so okay, so
now,
I mean, you know, that's cool, but isn't there any more to the story?
there is, okay, because we still have a video camera running out there.
Well, yeah.
That's eating up and saturating that channel still. So I go over here to the Clean Air tab, and the first thing that I've got is a video camera, which is active.
How do you know that that's a video camera?
Well, because when we do the classification, we're looking specifically for the PAL or the NTSC sync signals. So video camera, very, very positive hit. I've had people ask me, if you see a video camera, could it be something else? No.
Really?
It's absolutely video. We see
You've really
the sync
profiled
word
it
from
down
it.
to that level.
But now that we've got the video camera up and running,
Holy smoke, man.
this is called the zone of impact, okay? And if I hover over top of that, what we're seeing now is that we've got an active interferer, okay, at 100% duty cycle. You see he's positioned him on the map. Now this segment around it, that opacity changes with severity. So really quickly, you saw your reaction to it. Even if I don't understand RF, I know that can't be good.
I know red ain't good.
Okay, red ain't good, all right? So if I drill down on this just a little bit further, I can bring it right back around, and we can take a look at this real quickly from the AP standpoint, okay? And what we're seeing in the Spectrum right now is basically that video camera right there that he's seeing at minus 49 dBm. So we're still watching all the channels. But the point of this whole thing was that we've got a problem, and we still have to solve that problem, and that problem is that video camera right there on the map.
Man.
So now we know how bad it is, where it is, and what we need to do about it. And when we disconnect that, we're going to put the network back the way it used to be. So the tools are what's really important for the people afterwards. We kept the users up, but now you've got a way to go back and reclaim that bandwidth which has been lost.
That is really pretty darn amazing, man. I really, wow. I'm absolutely impressed. And that's all coming from the Sage that's picking that up, and
That's
then
coming from the AP, yes, sir.
which is taking us from out of the passive role of, hey, you got something out
Right.
here.
And this
What a
is where
bummer.
an overlay solution or an overlay competitor solution doesn't have that information that's that concrete that they can go back and make decisions on. We put that intelligence at the edge of the network where the problem is.
Well, and the thing that impressed me, I mean, there's a lot of things obviously impressed me about the Simo, but it impressed me that you actually told me what it was.
Yes.
You know, so now when I go looking, I'm not saying that there's something in the ISM band that's causing me problems, and I'm looking for it. It's like, oh no, it's a video camera. And now I'm actually tracing it down and saying, that's the video camera right there.
The other thing that we clocked in too, and let me go down and show you this, when that happened, we logged that. Okay, so we've got a persistent Wi-Fi interferer event. We've also got a major air quality event. That video camera is liable to be persistent. So any other AP that's in that area, what we want to do is mark that. We want to keep that AP off that channel until we resolve this. So we did both. If I take a look real quickly down here, you'll see the major AQ event. If I look at those details, it comes right up and tells you that that was a video camera that caused that.
That is really cool, man.
Okay.
That is
And
really,
like I said,
really
the
cool.
persistent event has been logged for that AP, for that channel. we're going to avoid going back to that channel. So it won't let the next iteration of the system algorithm won't let the AP go right back to that channel. I'll have to clear that now that we've cleared the interference.
And then once you clear it, it'll reset itself.
It'll reset itself.
It'll self-heal.
Absolutely.
Everything's going on.
Everything's good. It's already self-healed. We just need to go get our bandwidth back.
Oh, right.
Okay.
Right,
so we've just lost a segment of bandwidth. But it gives you the time to do that. It's sort of like if you had 2 power supplies in a server and you lost one of them, you're golden. But you do want to get another power supply back in that server.
Right, because you're kind of limping along.
Yes, you are.
Wow, man, I am absolutely impressed. That is really pretty cool. I mean, the fact that we know what it is, the fact that we can self-heal, plus we're recording and have the intelligence to let all the other APs know about this, man, dude, I don't even know what to say.
Well, that's where the system integration comes in. But the actual event, when you do it out at the AP, it knows first.
Well, Jim, thanks a lot, man. I really do appreciate it. That
Jimmy
is
Ray,
one
thanks for
very
having me.
impressive demo.
Okay.
Well, Jim, let's actually design one of these systems out.
Okay.
Let's see what it takes to deploy this. I mean, as an engineer, I'm looking at this. I'm thinking, pretty darn cool.
Okay.
Looks pretty neat. But look, Cisco, I've already bought a whole bunch of APs, and you're not coming here and telling me I got to take all these out, are you?
No,
and I
that's
gotta
an
replace
option.
them. Well, but it's not mandatory, is it?
It's not mandatory.
Okay,
No.
well, let's talk about. Let me
Okay.
bring up a design slide here.
Sure.
And there's no better design than an empty plate. So
Okay.
let's take a look. What does it take to put this in?
2 modes for the APs, okay? We have monitor mode AP, local mode AP. Now, key difference for this is we are working on one channel with a local mode AP. Now, the persistent stuff or the avoidance stuff that I showed you, we give the AP that has the sensor the ability in local mode to make those decisions, like that video demo.
Okay.
All right. In monitor mode AP, we're not actively serving a channel. We're operating in an overlay mode. So in the scenario that you talked about, if we had an existing installation, we'd probably want to start with some monitor mode APs as an overlay. You still get location. You get all the information that I showed you afterwards. What we won't do is change those channels because they're not actually serving channels. Okay?
It's just listening.
It's just listening. Now, local mode APs, of course, every AP being a sensor, that gives me the ability at the local mode of the AP to make decisions local to that AP for that AP.
Okay.
Okay.
Is there a hysteresis effect that once I make a decision on this AP, it ripples back through the system?
Extremely good question. No, we've actually been working with RRM now over the last several revs to build into that the small cell capacity, and when we make a decision to trip off to a different channel, it's not a random decision. It was a previously considered channel. So
cool,
we don't impact the channel plan greatly when we make that move. It's an intelligent move.
Oh, okay.
Okay.
All right.
All right, so monitor mode APs, when we deploy those, we want to deploy those at about a 1-to-5 ratio. Okay? You need the controller, the basic system.
1 to 5 what? Per
1 to 5 per legacy AP.
Oh, okay.
So I want 1 monitor mode AP per 5. Now that's give or take some depending on the density, but the coverage area of the monitor mode AP, since it's just listening, is actually quite extensive. Okay. In LMAP mode, we're going to put it in the local mode. We're going to put it in as a direct replacement. Now, what most people are doing, okay, folks that have this, there's significant advantages to having the local mode AP and having that device avoidance and being able to avoid those interference.
Yeah. I mean,
okay?
it's making all the decisions.
So if you've got a critical area, for instance, let's take a hospital, okay, you've got an emergency room or an operating theater, maybe you put in monitor mode APs for the rest of the hospital so that you're aware and you get the alerts from the system about devices that you want to know about. But in the critical areas, you give it that persistent device.
Okay.
Okay. I think people are going to see the value. Certainly if you're on a refresh cycle, you definitely want to consider this because the AP itself is outstanding as far as an 802.11n AP. It's far better than 1250. We've got new releases of Client Link in there, so it's an absolutely fantastic AP in spite of the spectrum.
That's be pretty good to be better on 1250.
It's
That's a
very
good AP, man.
Base system is a WLC. All you need is a wireless controller and an AP that has spectrum-capable chipset in it. That is the 3500 AP. And with that, you
The
get reporting on
3500
the
is the AP that
is
has
the AP
the Sage
that has the
chips.
spectrum. Yep.
Okay.
Okay. So that's what I brought here today, and we've got up set around the shelves. That's the basic system. Add to that WCS, you get history. Okay, so now we can monitor the air quality because the WLC is actually only going to show you what's happening in real time. We can alert on that.
Yeah.
Okay, but it's going to show you what's in real time. So for those that wanted to integrate it into another system, we can use a new feature called upstream or northbound alerts, so we can tie into any SNMP receiver. But
Wow.
with WCS, we have those charts and those graphs, and of course it's built for location. And then the final piece of that is the mobility services engine. All right. And if you add the mobility services engine, what we get is the location. Okay? And that's when we can triangulate all those pieces together, which was not an easy task. I think if you understand the local mode system, we're listening on one per channel.
Right.
Okay. So if I get an interferer that's wideband up, that's no problem. I've got, channels 1, 6, and 11 covered, and wideband's going to be covering the whole thing. I hear that from 3 APs. If I go down to a narrow mode, like a single megahertz type signal, like a video camera, only 1 in 3 of those APs is going to hear it.
True.
But at a normal density, okay, for normal coverage, and we're not talking about, any high density scenario for multi-hundreds of users. Normal density, we hear it in enough APs to actually get a location, and that's done at the MSE. We're not doing that with a simple X and Y location. The first challenge that we had to solve was identify that interferer as the same interferer at each AP, and then all of that flows back up to the MSE, and the MSE is doing the location calculation and what we call merging and clustering. So we'll have a series of 4 or 5 APs that are identifying the same thing, and then it's going to track that continuously.
Okay. So we're putting a local mode here on the center frequency, and that center frequency is managing all the 22 megahertz offsets, and then we got another one on another center frequency, and it's managing any of the offsets.
Yeah. And so what you wind up with, okay. All right, so I've got an AP here on 1, 6, another one over here on 11.
Yeah.
Okay, let's put another one over here on 1. Another one over here on 6.
Yeah.
And another one up here on 11. Probably not optimal. Okay?
Right.
So if I have a narrow band, all right, like a video camera.
Yep.
All right, which is what we just did. Let's say it's on channel 1. I'm actually going to hear that at these 2 APs. Okay?
Are you hearing it because those APs are talking to each other on the back end system?
No, I'm hearing it because those APs are on channel 1, which is over in that part of the spectrum. Okay. So that's a narrow band. I've got 20 megahertz in my channel. I've got 100 megahertz in my spectrum.
Yeah.
Each one of these is covering 20 megahertz. If that 1 megahertz hits this AP, I'm going to hear it at that one as well.
Okay.
But I won't hear it on 6 and 11. That's local mode. Okay. But if I do a monitor mode, I'm scanning the entire frequency span. So I'm listening to all 100 megahertz. Doesn't matter whether it's narrow or wide band.
Okay.
All right.
I'm with you.
Downside to that is I'm not measuring this at every AP. Let's assume that we did an overload or
You're just
an
taking
overlay
a statistical
mode.
sampling.
I'm seeing the entire spectrum, but I've got other APs that are operating, so I have to convert that now into a location and assume how it's impacting those APs.
Okay.
Those
I'm with you.
APs are going to have to make their own noise judgments on their own because I'm not going to directly control them.
Okay, so it's almost then like having a laptop sitting there with Spectrum Expert running.
Exactly.
Okay.
That's exactly what it is.
Okay.
So we get full knowledge, we get alerting, okay? The one thing that we don't get is the automatic system avoidance.
Okay, that makes sense. That makes sense.
But RRM itself will see the interference at a point in time, and we can correlate that as an administrator and understand what's going on in the system.
Okay. Can you mix the two?
You don't want to mix, well, actually, if you're doing all spectrum expert or spectrum capable APs with the 3500 and the Clean Air system, mixing both monitor mode and local mode APs is absolutely the best of all worlds. Okay? That's the Cadillac. What you get is because I can hear the neighbor messages from each one of these APs, I can now position that monitor mode AP, and all of that information can be used for location. So everywhere I have a monitor mode AP, even if it's a narrow signal, I'm going to hear it and trigger on it automatically, and it provides me another point of reference. You don't want to mix local mode Clean Air APs and non-Clean Air APs. Okay?
In local mode. Well, that makes sense.
Mode.
Okay, I can see that. Sure.
Right.
Because you've got a dedicated channel and you're watching that. Okay, I can see that.
Well, and here's what's going to happen. If you did that, RRM likely to put those Clean Air APs, let's say it puts them all on the same channel. Okay, you still have this scenario here where you're only hearing 20 megahertz of that spectrum, and if it puts all of them on channel 1, you've got your legacy APs that are still hanging out there in channel 6 and 11 with no spectrum sensing capabilities.
Gotcha.
Now, the nice news about this in the monitor mode is it supports the Clean Air, supports location resolution, our advanced WIDs, rogue detection, so everything else that a monitor mode AP can do, we can do at the same time that we do Clean Air. So you lose nothing by putting in a monitor mode AP. You actually gain a lot of function and value.
That's pretty cool, man. Let me, in the less than a minute we have left here, one of the things I want to ask, and so if I made an investment and I went ahead and already bought Spectrum Expert, and I've got it on my machine, is there any? Can I still use that? Does that provide any value? Can I do anything
Absolutely.
additional with that and these APs?
Yeah, absolutely. I won't leave home without Spectrum Expert. I mean, once you get into a
because it almost
scenario,
sounds like I'm kind of saying that I can negate this, but
well, let's say that your interference is coming from another floor in the building where you don't have AP coverage or a neighbor's space or something like that. You're going to have to walk off site with that. So there's always going to be use for Spectrum Expert. Or if you're using a monitor mode and you narrow this down to a corner of a building, there's nothing more valuable to have in your hands than an RF meter that you can walk right up to the interference with. So it's still very valuable in my opinion. And you can treat this, you can bring it into the system as well and alert on it in WCS. So that's already been taken care of.
that's really cool, man. I really, I just am shocked. I mean, I'm a hardware guy. I'm amazed that we've rolled a spec in an access point, and now we've kind of rolled this into a whole new way of RM. I mean, this is really pretty darn amazing. This is some pretty new country here, man.
At the
this
speeds
is good
we're
stuff.
operating at, it's what we got to do now.
Now, my assumption is that now I know we're really just about out of time here, but my assumption is because the way we did this in hardware is that the statement, if you like it now, just wait because it's going to keep getting better because you do have a ton of scalability in the product because of the way it was implemented in hardware.
We have a lot of smarter guys with a lot of smart ideas right now. So
I love
we can't wait for the second release.
Well, Jim, man, thank you so much.
Jimmy
I
Ray,
am
thanks so much
absolutely,
for having me
absolutely
out.
impressed. Thank you, man.
Okay.
Thank you so much for watching today's show. Certainly hope you enjoyed it. However, we need to hear from you. We want to get your feedback. So just click on that evaluation button. Let us know what you like or what you don't like, what you'd like to see more of. Then check out all those additional links right there on the console. You can also find more information at techwisetv.com, links to the other shows, podcasts, Facebook, and Twitter link, and, of course, our blog. Well, that does it for the show. On behalf of all of us here at TechWise TV, thank you so much for watching, and we will see you again next time.
Rolling. Keep those cameras rolling.
Roll high.
Roll high.
Try to do it without the shoulder shimmy. Thank you.